Welcome back to the second segment of our discussion. We're still talking, learning from observing the night sky. Simpiwe, just before we went for the break, you were talking about how these concepts, integrate with each other. It's hand in glove. That link is very important. What are some of these concepts that you want to share with us?
Yeah. So we'll teach these things in terms of subjects and certain topics, but at the end of the day, once we have taught these things to learners, we must make them understand how they link together. Okay. That is how they'll be functional human beings, understanding all that is around them. So when I like to touch on this is to say we're on planet Earth. We are held onto the ground by gravity.
Okay.
And it's not just us. There's this column of air from which we get the gases like your oxygen that we need. Okay. Then you've got your nitrogen, your carbon dioxide, and all of that.
Okay.
Also
in terms of chemical composition.
Yes. Okay. It helps us also as this shield from this natural radiation, right? Now it is us moving, sort of hovering away from
now
the
we're
ground.
taking off.
Yes. Okay. So you've got all these systems within the atmosphere itself, but moving beyond the atmosphere, you get to a place where other people might say it ends at the thermosphere. Okay. But if you read more, you'll find there's a thermopause, and then there might be an exopause.
Lots of terminology.
And then you move out into the outer space. Now you're looking down on planet Earth. You are able to see all the other planets going toward the sun, which is our star. Okay. In another direction, for example, you might see the gaseous giants moving further away from the sun. And then that would be our solar system, where you are having the planets, the dwarf planets, your asteroids, and your moons, and all these other things.
So, at the level of, grade 8 and 9, these dwarf planets, asteroids, can we conceptualize them? Do we have images? What resources can we maybe?
We definitely do have resources, but I'll share a bit more on those ones as we talk. But you are able to even have jingles, for example, just so they understand the sequence away from the sun. Okay. For example, my very energetic mother just showed us ninjas. You can imagine a mother doing fly kicks and cartwheels, which then talks to my Mercury, very Venus, energetic Earth, Mother Mars, just Jupiter, showed, which is Saturn, Uranus, Neptune.
This is the orientation.
Fun things that they can recite because and know the order.
In physics, we talk your Roy G. Beef.
Exactly.
In terms of the
you
spectrum.
Need these things that, in as much as it has a memorization, but at least it helps them that when they need to know these things, of course they'll read other things for understanding.
And the use of models also, in
simulations, models, and all of these
becomes very important.
And so you are even able to, for example, if we talk of the solar system and then we talk of the Milky Way galaxy, you are able to take a saucer, put some water, sprinkle, black pepper, and you'd have these particles, and then you swirl it. Okay. And then you'd see all these things.
It simulates the orbiting,
which is movement, orbiting of our galaxy, for example, and it having that spiral shape. And then you'd have those sort of particles moving along with it, and at the center, at some point, you'll find some of this settling down, and you could easily say that is where it is believed to be the supermassive black hole, which we have at the center of this particular galaxy and any other galaxy. So these things that easy for them to do. And they are able to visualize.
This is what I want to think of as what we often refer to as shoestring science, or a shoestring budget, using readily available materials.
So not even black pepper; it can be silt, some type of soil, or whatever else. It's just the water having some particles, right?
It just has to float.
It could easily be pieces of paper, different colors with the marker and all of that.
And also we saying at the same time we're addressing that misconception of spinning, rotation, orbiting, revolution at the same time.
Within the text, you'll find many of these terms used. But perhaps as a teacher, sometimes you'll find that people are struggling with the medium of instruction. So yes, you'll find rotate being mentioned, revolve being mentioned. But if you are able to, so that learners don't confuse them because they might sound similar, or even when you write them, then you're able to say rotate actually means to spin. You've played a spin top, you've played spin with coins and all of these things. They visualize it. And then revolve can be orbit. This is now something moving around another object.
All right.
And so they internalize these things. Then it's much easier for them to just know, which particular term now, but they understand what is happening.
Another one that I'm thinking of immediately, the night sky, this quite a lot.
Whenever we talk about astronomy, as a disclaimer, I would say they often use the observable universe. It is them saying we don't know everything. We don't foresee ourselves doing everything.
That's an
it's so
interesting
fast. And so we are telling you that when we tell you 1, 2, 3, 4, and 5, it's what we have observed. It's what we have tested.
There could be more beyond that.
There could be more. We could find something new tomorrow. I mean, we talk of our planets in the solar system. There are things called exoplanets, which are planets going around other stars, which are far away from the one where we are.
Speaking of that, kindly enlighten us further the issue of measuring distance, because the universe is so vast. You know, we talk about many galaxies. You know, the Milky Way being one of them. The issue of measuring this distance, we don't talk kilometers.
Yeah, very interesting. Let us say, for example, we are here. We are seated here. If I were to want to measure from here to perhaps a meter away, I might use centimeters.
Okay.
But if we're talking from this corner of the room to that other one, it makes sense to use meters.
Okay.
And so once you get up there and you're looking at those distances, it doesn't assist you to use meters and kilometers. So we use the speed of light. And then we talk of distances traveled by light per unit time. For example, you would say light from the sun to earth, 8 minutes.
Okay.
So light
is that how close, for argument's sake?
Yes. Light takes 8 minutes. But then the other nearest star, light takes about 4.2 years to get to us from that star. Yes. And then you talk of, for example, now astronomical units. And that one is usually us talking about distance between the sun and, say, a planet in the solar system, etc. Okay. And so you have to sort of escalate.
Okay. Then we talk of light years.
Yes, so light years, distance traveled, by light in a year.
A period of 365 days.
That is correct. And if you have to convert those to kilometers, it's very big, and it helps you to just say 1 light year.
Okay. Now let's talk about the misconceptions that obviously come up with, around the concepts of, the Milky Way as a galaxy together with the atmosphere, because we want to tackle the two at the same time.
Let me begin with the atmosphere, the closest one to us. Sometimes we say the atmosphere is made of air. And then people are like, you can't touch air, it's light and all of that. And then people feel it's inconsequential. But it's very important. Hence we talk of atmospheric pressure at times. Because it itself is...
In terms of composition of gases.
Yes, it's significant in the gases that we benefit from, but also the column itself. Because air occupies space. It has mass, etc. And then we move into the night sky and you are looking at all these other things. Misconceptions will be around the movement and the motion of these objects, where people use the wrong terminology. Or you ask a person, how does the earth move? And they'll say from left to right, clockwise or anti-clockwise. It confuses people. But if you are saying the earth moves from west to east.
On a plane.
Pardon me?
On a plane, west to east.
West to east. In that way, you can even explain that the sun is not so much moving as the earth is. So if you had planet Earth here and we had the African continent, the sun is somewhere here. And planet Earth moves toward
the sun.
Toward the east.
Or the east.
Toward the east. Are you getting my point? African continent receives the sunlight. And then it goes into darkness, and then it's South America, and it continues doing this.
So now we're also speaking to the issue of, day, night.
Day and night, yes.
Time zones.
Exactly, all of these things. And so you know that the land masses on planet Earth are being exposed to the sun, at different times, at different hours, etc., etc.
Right.
And so at least if a person understands that.
So what are some of the...
It's never changed.
Yes. I'm also interested in some of the, concepts that have got to do with the night sky. What are some of the, unique things that we take for granted as far as the night sky is concerned?
What we take for granted is the distance. Let us talk about the sun. People might believe it's the hottest, it's the brightest, it's the biggest. But it simply is that it's the closest one to us, and we rely so much on it. But it is not...
Can you also link that with the uniqueness of planet Earth in terms of sustaining life?
Most definitely. So with the other ones that you see in the night sky and they are tiny dots, it simply tells you they are very far away. But those might even be bigger and hotter, just further away, and it takes longer for the light to reach you. Now coming to this importance of where we are, we call it the Goldilocks zone. This perfect spot that we are just the right distance away from the sun to be receiving this heat and not being overloaded with this radiation, and that you have the atmosphere which is protecting us from some of that radiation, and then life is supported.
Now, I want us to go, deeper. Surely there are a lot of misconceptions, which, unfortunately, some of them as teachers, we carry them into class and relate to the learners. But it's clear. I want us to talk about the resources that can be used, your institution being one, destination of note, in terms of getting that hands-on experience and exposure to both, educators and learners alike. We'll talk about that after the break. Colleagues, that was it as far as, going deeper and some of the misconceptions surrounding, planet Earth and beyond. Hopefully, you start finding it fascinating in terms of some of these, facts that Simpiwe is bringing forward. Let's join each other after the break.